Hi everyone, I hope you were able to spend some time exploring the transformations of a quadratic functions activity. We're going to go ahead and review some of your answers and then take a deeper look at quadratic transformations. Changing the a value makes the graph. Hopefully you were able to tell from the activity it makes it skinny or fat. Some people also say narrow or wide. Changing the k value makes the graph move up or down. Changing the h value of the graph moves left or right. Hopefully you were able to see this as you completed the activity. The parent function, once again from the previous video, is y equals x squared. This is the transformation form of y equals x squared. A times the quantity of x minus h squared plus k. This squared tells us it's a quadratic function. The a gives us a vertical stretch or compression, or reflection over the x-axis. This makes the graph either skinny or fat or flipped over. The h gives us a horizontal shift, left or right. You may have already noticed this, but it is actually opposite from what it looks like. The k is a vertical shift up or down. This is a really important slide to come back to, so you may want to refer back to this as you complete your assignments. We're going to take a look at the a value first. If a is bigger than 1, for example 3, we have y equals 3x squared. This is the graph. The dotted line is the parent function y equals x squared, and the red function is y equals 3x squared. If you notice, it is making the graph skinnier. We call this a vertical stretch. It makes the graph skinny. If a is between 0 and 1, such as a fraction smaller than 1, like 1/3 x squared, it gives us this graph. This red function is wider or fatter than the dotted parent function. We call this a vertical compression. If a is less than 0, meaning negative, such as negative x squared, it looks like this. The red function is flipped over the x-axis. We call that a reflection over the x-axis, just like you see a reflection in the mirror. We're going to take a look at the h value. If we have x minus 3 squared, it looks like it should be going left, but this is what the graph is. The green function is x minus 3 squared. So it looks like it should be going left, but it actually shifts right. If we have x plus 3 squared, it looks like it should be going right, but as you can see from the graph, it actually shifts left. This is very important. Looks like it's going left, but it moves right. Looks like it should be going right, but it moves left. This is a warning to be cautious that this is opposite. So the equation looks like it is left, but it shifts right. Looks like it is right, but it shifts left. The only time it is opposite is for inside the parentheses. For k, if k is positive, like x squared plus 3, the graph looks like this. As you can tell, going from the dotted line to the blue line, this is a shift up. If k is negative, such as x squared minus 3, the graph looks like this. As you can see from the black dotted line of the parent function to the transformed blue function, we have a shift down.